Topic 3.3 Electric currents in conductors. So we can classify the materials based on the electrical conductivity in different types. First one is the conductors. Simply electrically good conductors. The substances which allow the flow of charges through them are called conductors. So example, metals. Most of the metals fall under the category of good conductors. In metals there are large number of free electrons and there are large number of positive ions. If the free electron uh, broken out from the isolated atom, then the atom should be converted into positive ions. So equal number of positive ions and also the equal number of large number of free electrons. So these free electrons are responsible for electrical conduction. That is the flow of these charges when we apply the potential difference between the two ends of the conductor. The electrons can flow from negative terminal to positive terminal. So this is called electric current. So due to the large number of free electrons, the good conductors are high electrical conductivity. So they are called as good conductors. But in the case of insulators, they do not allow the charges to pass through them because they have no free electrons. All electrons are bound to the atoms. So there is no free electrons. So there is no possible of current conduction. So they are called insulators. So another category, dielectrics. Dielectrics already we have discussed in the second lesson, second chapter, capacitance and potentials. That is, dielectric medium is placed in between the two parallel plates of the capacitor. So dielectric is the one of the type of insulators. The dielectric is simply an insulator, but in which the charge can be separated. So in a dielectric medium material, the charges, when we apply the potential difference between the both ends, so the electrons and positive ion can be separated at a small distance. So charge separation will occur, but there is no current flow. There is no flow of charge through the material, but the charge separation will be done when we apply the external electric field. So this type of material is called dielectrics. So dielectrics are also the insulators. So all dielectric materials are insulators, but not all insulators are dielectrics. Only few insulators, that is dielectrics, can store the electrical energy in this way. That is, when we apply the potential difference, that is the electric field, to the material, the charge separation, the electrons and the positive charges are separated by a small distance. So in this way electrical energy can be stored in this type of materials. So this is one type of materials. So conductors, insulators. Third category is dielectrics. Example of dielectrics are oils, synthetic oils that we are using in lead acid batteries and water, mica sheets, piece of paper, etc. At the same time, the example for insulators are glass, rubber, mica, plastic. These are insulator. They have not conduct the electricity through them. And metals and many liquids and some gases are acting as conductors. The other types of materials based on electrical conductivity are semiconductor and superconductor. Semiconductor simply silicon and germanium. Both the two metals only the pure type of semiconductors, and the compounds like gallium arsenide, indium phosphide, like these are acting as the semiconductors. We know the semiconductors are used at a wide range in electronics. So electronics are simply the department which deals with the semiconductors. So in which the electrical conductivity and also the resistivity exactly lies between conductors and insulators. So the electrical resistance, the resistivity of the materials are greater than the conductors, at the same time less than the insulator. Resistance means the opposition to the flow of electrons. So the same the less number of free electrons in the semiconductors compared to the conductors. At the same time, more number of free electrons when compared to the insulator. So the electrical conductivity lies in between conductors and the insulators. So this type of material are semiconductors. And there is a special type of material is called superconductor, in which the resistance is almost equal to 0. So the current will be more. So in this type it can be achieved at very low temperature. So example, mercury at 4.2 Kelvin. You imagine just 4.2 Kelvin. Normally room temperature is around 300 Kelvin room temperature. So just imagine the temperature of 4.2 Kelvin. It is not achievable under normal conditions. So at special conditions we can achieve this much of low temperatures. At this much of low temperatures, the resistivity will become 0 of the materials, for some materials. Example, mercury. So so many material compounds are there in which the resistivity equal to 0. So conductivity will be very more. So current conduction is very large. So this category is superconductor. Next we move to concept current carriers. We know though current means the flow of charges. Current I equal, we know the formula, Q by T. The rate of flow of charges is called current. So if the charges move, then it is called current. So the current carriers, it may be electrons or positive charges. At common, electrons, that is negative charges or positive charges. So in the conductors only they conduct the electricity, that is current. In insulator they do not conduct the electricity. So the conductors, so in the conductors we can classify the types of conductors based on solids, liquids, gases. In solid conductors, in solid conductors, the charge carriers will be electrons, because there are large number of free electrons, and also the same positive charges are there. But due to the mass factor, the positive charges will not move, and only the electrons will move. That is, if we apply the electric field, this is negative, this is positive. That is, potential difference is applied across a conductor. The electrons will move towards the negative terminal. The electrons will move towards the positive terminal. The current will move from negative to positive to negative. That is, current will move from positive terminal to negative terminal. So electrons, free electrons. So in the solids, according to the solid materials, only the current carriers will be the free electrons. So the positive charges will not move. So the only free electrons are the current carriers in the solid materials. But in the case of liquids, the current carriers will be negative charges, also positive charges. Negative and positive charges are the current carriers, because liquids, mainly the solutions of ionic salts. The solutions of ionic salts, they have positive charge and negative charge. If you take the copper sulfate, then here Cu plus and SO4 minus. So it is ionic salt. When dissolved in it is taken as aqueous form. So the copper positive charges and the sulfur, that is negative charges, will be there. So the both ions, positive and negative ions, will contribute to the current. So you see it is in the case of liquids. Then third category is gases. In gas materials, the electrons, free electrons are there. At the same time, positive ions are there. If the gas is ionized at very low pressure, and special conditions, low pressures, the gas can be ionized, and after that the electrons and positive ions are there. So both in the type of gases, both electrons and positive ions are the charge carriers, that is current carriers in the type of gases. As a conclusion, the current carriers in solids, only free electrons, and in liquids, both the positive charges and the negative charges, that is positive ions and the negative ions. Last, in the case of gases, the electrons, free electrons and the positive ions. So these are the current carriers in solids and liquids, gases respectively.